Today I'm going to show you all that you need to know in order to solve really interesting problems with square roots. And we have lots of rules that we can apply that helps us go about solving them. And I'm going to kind of go from the easiest rule all the way up to the hardest rule. So we're going to start off. What if we have a multiplication problem inside our radical sign, which is our square root symbol? Well, we know that we have to solve whatever's inside our symbol, but the thing is that we can see is that I could take this radical sign and I could put it over the 9 by itself, and I could put it over the 16 by itself. And the reason why I want to do that is because I see 9 and 16 are both perfect squares. And if I can get rid of that radical sign and just get it down to what that answer is, it's a lot easier for me to do. So whenever I'm multiplying, and notice it's multiplication, it's not addition, whenever I'm multiplying, I am putting each number under the radical sign under its own square root symbol. Then I just take the square root of 9, which is 3. I take the square root of 16, which is 4, and 3 times 4 is 12. So it's easy to break down the problems. Let's go a little bit harder. What if I have a variable? Well, the same rules apply because this is 36 times x squared. It's multiplication. So my first step, I'm going to put them both under their own square root symbol or radical sign. Now the square root of 36, we're lucky because that's a perfect square. It's made up by 6 by 6, so I know that's 6. And remember, a squaring of a number and a square root of a number, they're opposite operations, so they cancel each other out. So the square root of x squared is x. Let's go a little bit harder. Look at here. I start off with 25 times 6. I put them both under their own radical sign. I'm lucky because 25 is a perfect square. 5 times 5 is 25. But 6 is not. And if it's not a perfect square, it's absolutely okay to keep it under its own radical sign in the answer. So here, I put 5 on the outside. It still means times because there's no operation there. But I keep my 6 under its radical sign. So sometimes you're going to have a combination of the two. You don't always have to get rid of that radical sign. All right, let's go a little bit harder. So let's do 24 times s squared under that radical sign. Well, 24, okay, that's not going to be a perfect square. But if I can factor out any perfect squares, I do. So I think of the factors of 24. I think 1 times 24, no, that doesn't help me. 2 times 12, no, because neither of those are perfect squares. 3 times 8, no, none of those are perfect squares. 4 times 6, yes, because 4 is a perfect square. So I rewrite 24 as 4 times 6, knowing that I'm going to put the 4 and the 6 under their own radical signs. Now this s squared also gets to go under its own radical sign. So I'm going to factor out any perfect squares I can get. So the square root of 4 is 2. That goes outside now. That radical sign is gone. The square root of s squared is s. That radical sign is gone. The square root of 6, I can't do anything with. So I'm going to leave that square root of 6 inside, and I'm going to put together 2 and s on the outside. It's kind of like a puzzle that we're unlocking here. You got to always go back to those factors. So let's go now to our fractions, because lots of kids don't like fractions. But remember, you're putting everything under its own radical sign. So we're going to start with the easiest one. If I have 9 divided by 4 under that square root symbol, I'm going to do the square root of 9 by itself and the square root of 4. I'm lucky here because both 9 and 4 are perfect squares, and I get 3 over 2. And a lot of times we just leave it as that improper fraction form. Perfectly fine because it is coming back and representing those numbers that were in that radical sign. Let's go a little bit harder. What if we have the square root of x divided by 16? Again, I'm going to put them under their own square root symbol. Now, I can't do anything with the square root of x because it doesn't have an x squared. So I don't even know what x is, so I just have to leave it under that radical sign. But the square root of 16 is 4, so that would be my final answer. I think the biggest thing is you have to get used to numbers being under the radical sign. All right, let's go a little bit harder. 32 divided by n squared, and I want to take the square root. Well, 32, I've got to go back and I got to think, how can I break that down? And I know that 4 times 8 is 32. And I know that I can break 8 down to 4 times 2. Now notice I broke the numbers down twice. So whatever you get under here, that has to go back and equal that 32. But I'm looking for those perfect squares. So this is where that challenge starts to happen. So I have the square root of 4 by itself, the square root of 4 by itself, the square root of 2 by itself, and in my denominator I have the square root of n squared. Well, the square root of 4 is 2. The square root of 4 is 2. The square root of 2, it's not a perfect square, so I'm going to keep it under that radical sign. And the square root of n squared, remember they cancel each other out. So I'm left with 2 times 2, which is 4 on the outside. I leave my square root of 2 on the inside, and I have n on the bottom. You just have to take your time and break it down. So what if we have no numbers at all? What if we have the square root of n squared? Well, we have to go back to our rules for multiplying exponents. And I can break 9 into n squared, because that's 2, n squared, n squared, n squared. So I have 2, 4, 6, 8, and I need one more n. The reason why I want to do that is I know that when I put n squared under a square root, it factors out. So I can factor out this to an n, this one to an n, this one to an n, and this one to an n. I can't factor out just the square root of n because I don't have that square there. So that has to stay under the square root symbol. So now I put it back together, but remember, it's the same base being repeatedly multiplied, so I can use an exponent there. So my answer is n to the 4th times the square root of n. And we can do that over and over and over with even more complicated numbers. So as you can see, basically any number that we put under a radical sign, we usually can factor out, and we can even have variables. And so it's all about the game of finding every factor you can factor out and get outside the radical sign, and whatever you can't, you've got to leave inside. I love working with square roots. I hope you have fun with this as well. Good luck.